Hello everyone, my name is Yincheng from University at Buffalo. Today I'm going to introduce our recent work, the EchoWhisper, which is an acoustic-based silent speech interface for smartphone users. As nowadays, it seems like the voice interactions are everywhere. Compared with typing, the voice interactions is much more convenient and efficient. And for sure, there are tons of mobile apps that support voice interactions. And also, we can use voice interactions in many scenarios, such as the subway, noisy street, and also inside the room. However, is it always be convenient and secure for using voice chat? The answer is no, because sometimes we don't want others to hear our sensitive topics. And also in some silent environment like the library, it's not very convenient to make the sound. And also, the voice can be easily recorded in public places by malicious users, which will increase the risk of voice synthesized and replay attacks for the potential use, such as the voice string-based authentications. So now we're asking a question, is there a way to use smartphone for silent speech interactions without vocalizations? And then we have some interesting findings. If the user is holding the phone and is speaking, and if the speaker is transmitting an acoustic wave, and when the acoustic sound reaches the user's mouth, according to Doppler effects, the motions of the mouth will cause slightly frequency change of reflected echoes. If we see the figures on the right side, if we move the tongue and the mouth, we can see clearly frequency change. And also, if the user is speaking different words, such as today and assistances, we can see the consistent patterns for the same word, as well as different patterns for different words. Based on the interesting findings, we will propose our EchoWhisper, a novel silent speech interface. So when the user is implementing silent speech, our smartphone will emit acoustic sounds as the 20 kilohertz ultrasound. And then once smartphone receives the reflected echoes, it will be first calibrated and then feed into our echo enhancement module, including the noise cancellation, as well as our data augmentation strategies. And then we will segment the audio signals for different words. And then we will remove the noise caused by the airflow, and further extract the spectrogram as our features, and feed the features into our echo nets to recognize the patterns. And later we can recognize the speech content. So in our experiments, we use 3 different smartphones, and we enroll 5 different users. And in the experiment, we ask users to hold in the smartphone and speak and implement silent speech for 45 different words, including high-frequency words and a multiple pair of confusing words. For the recognition performance, we compare our echo nets with some popular deep learning network, and our echo net achieved the lowest word error rate. And also, we implement the individual analysis of our accuracy among different type of words in terms of the number of syllables, and also the confusing words, which is hard to be recognized by the lip readings. And we get accuracy of 91% among 45 different words. And also we implement the usability analysis of our systems. So we analyze the word error rates along with the different training data lengths. And also we analyze the power consumptions and word error rates on 3 different types of smartphones. And then when we further evaluate the robustness of our systems, including the different smartphone orientations and different smartphone positions, including the top, middle, and the bottom relatively to our mouse. And our beamformed signals have a lower word error rates compared with the standalone top and bottom microphone. And also we evaluate our system performance for different distance between the smartphone and our user's mouse. And we can achieve the best performance along the range between the 3 centimeters to 7 centimeters. And also we analyze the performance according to the different background noises. And also we mimic the performance among different users' body motions. And also we evaluate our system performance, including the interference caused by our nearby devices, which is also transmitting a 20 kilohertz ultrasound. So in this work, we propose a smartphone-based speech interface, the EchoWhisper, which leverages a dual microphone and a speaker to capture and recognize users' mouth and tongue movements without vocalizations. And thank you. If you have any question, you can contact us through the email and also scan the QR code for further information.